On the morning of December 26, 2004, a massive undersea earthquake off the coast of Sumatra set a tsunami racing across the Indian Ocean. Along a stretch of Thai coastline, home to the Moken people, sometimes called sea nomads, something strange happened before the water ever arrived. Elephants working near the shore reportedly broke free and bolted for higher ground. Dogs refused to go anywhere near the beach. And the Moken themselves, watching the ocean pull back farther than they had ever seen it pull back, and hearing the frantic behavior of birds and insects around them, did not wait for an official warning. They grabbed their children and ran uphill. Their community is often cited as having suffered remarkably few losses that day in a disaster that killed over 220,000 people across the region. That was not luck. That was inherited knowledge, passed down for generations, about how to read the natural world before it turns violent. And the Moken are far from the only culture in human history that built survival around watching animals, whether the danger was rising up from the ground as an earthquake or gathering overhead as a storm. Long before seismographs, long before satellite weather tracking, ancient humans were paying very, very close attention to how the creatures around them behaved, because sometimes that attention was the only warning system they had. This same pattern turns up on nearly every continent, wherever a community lived close enough to nature to have no other option but to watch it carefully. So how much of this is real science, and how much is just a good story that happened to survive? The honest answer turns out to be more complicated and more interesting than either extreme. Some of the earliest recorded accounts come from ancient Greece. Writers including Aelian and Pausanias, working centuries after the fact, described the city of Helike, destroyed by a catastrophic earthquake and tsunami around 373 BC. According to their accounts, rats, snakes, and wolves were seen abandoning the city in the days beforehand, as if sensing what was coming. We cannot verify this. The way we would verify a modern data set. It is an old account, written well after the disaster, but the story persisted for a reason. Something about that pattern, animals leaving before the ground failed, felt true enough to record and repeat for centuries. In Japan, the connection became embedded in folklore through namazu, a giant catfish believed to thrash beneath the islands and cause earthquakes. After a major earthquake struck Edo, modern-day Tokyo, in 1855, woodblock prints called namazui exploded in popularity. Fishermen had long noticed catfish growing agitated before seismic events, and while later scientific attempts to formally confirm this connection had produced inconsistent results, the folklore itself functioned as something real, a way of encoding a pattern people had genuinely noticed into stories simple enough to survive. On the other side of the Pacific, researchers studying Native American oral traditions along the Pacific Northwest coast have found stories describing a battle between a giant thunderbird and a whale, shaking the ground and raising the sea. Youth Ludwin and her colleagues have argued these stories likely encode genuine memory of a massive earthquake that struck the Cascadia region around the year 1700, an event later confirmed by sediment layers and by Japanese records of an unexplained tsunami. If that connection holds, entire coastal nations were preserving detailed disaster knowledge inside mythology itself, because story is what survives and writing does not exist yet. For a long time, scientists treated all of this as folklore, interesting, but not rigorous. Then in 1975, Chinese officials evacuated the city of Haicheng Just hours before a magnitude 7.3 earthquake, a call based partly on reports of unusual animal behavior, snakes leaving hibernation in the dead of winter, livestock refusing to enter barns, alongside documented pattern of smaller foreshocks. Thousands of lives were likely saved, and it remains one of the only successful large-scale earthquake evacuations on record. But scientists still argue over how much credit belongs to the animal reports versus the foreshock data, especially since the very next year, the devastating Tangshan earthquake struck the same region with no warning at all, killing an estimated 240,000 people. That failure matters just as much to this story, proof that animal behavior alone has never been reliable enough to guarantee a prediction. Still, more controlled research kept finding oddly specific patterns. Biologist Rachel Grant, publishing the Journal of Zoology in 2011, documented common toads abandoning their breeding colony in Italy 5 days before the 2009 L'Aquila earthquake, returning only once the aftershocks had settled. Out on the water, marine biologists Michelle Hupel and Robert Huiter tracked tagged black-tipped sharks that fled a Florida bay for open water as barometric pressure dropped ahead of Tropical Storm Gabrielle in 2001, a pattern that repeated 3 years later as Hurricane Charley approached. And in 2014, ecologist Henry Strebe and his team, publishing in Current Biology, tracked golden-winged warblers that abandoned their breeding grounds in Tennessee more than 24 hours before a storm system that went on to produce 84 tornadoes. Why that storm was still hundreds of miles away. More recently, biologist Martin Wickelski and his colleagues tagged goats on Sicily's Mount Etna and watched them flee downslope hours ahead of volcanic eruptions, while a related study tagged cows, sheep, and dogs in earthquake-prone parts of Italy and recorded measurably restless movement hours before the ground actually shook, all part of an ongoing research effort called Icarus. So what are these animals actually picking up on? Researchers have proposed several overlapping explanations, and it is worth being honest that none of them are fully settled science yet. Some animals, including certain birds, can detect infrasound, extremely low-frequency sound waves below the range of human hearing, which powerful storm systems generate and send traveling for hundreds of miles before the danger physically arrives. Many species are also far more sensitive than humans to sudden shifts in barometric pressure, using it as a built-in early warning specifically for approaching storms. For earthquakes, the shortest warnings, the seconds right before shaking starts, have a fairly well-accepted explanation. Animals may simply feel the faster Wooker P waves that arrive moments ahead of the slower, more destructive S waves that humans actually notice. The longer warnings, the days before cases like the Italian codes, stay far murkier. One contested hypothesis, developed by geophysicist Friedemann Freund, proposes that rocks under intense underground stress release positively charged particles, altering the electric and chemical environment near the surface well before an earthquake hits, something certain animals might be uniquely sensitive. It is an intriguing idea, but it remains unproven, and plenty of researchers stay skeptical. That uncertainty matters because modern earthquake warning systems, built on seismographs and satellites, still typically offer only a few seconds of notice once the ground actually starts moving. If animal behavior really can offer hours of advance warning, even imperfectly, researchers like Wickelski argue it is worth pursuing seriously rather than dismissing as folklore. Nobody is proposing we replace the seismograph or the nervous goat, but combining both approaches, ancient observation and modern instruments, is exactly the direction this research is now heading. What we are left with is genuinely humbling. Ancient societies, with no understanding of tectonic plates, atmospheric pressure, or infrasound, built entire survival cultures around one simple, repeated observation. When the animals act strange, pay attention. They could not explain why it worked. They just knew, often enough, that it did. And thousands of years later, with sensors, peer review, and satellite data, we are still just catching up to what they had already figured out around the fire.